Erecting a steel structure is a dramatic and often breathtaking process of assembling the fabricated steel members at the site. Frequently, these pieces will have to be assembled under difficult conditions, where it is not easy to maneuver them to align the holes and make the members fit. This is why precision in the detailing and fabrication processes are so important. Typically, erection is done by lifting and placing the steel members in their appropriate positions, and then temporarily fastening them with several bolts or welds. At this point, the structure is capable of supporting only its own weight and cannot resist lateral loads. It must be temporarily braced so that it will not fall over during construction. When a worker receives a member for erection, he lines up the holes by running a pin through them. Then he puts in several bolts and temporarily tightens them with his wrench. During this process, the crane operator plays a very important role. It's his job to deliver the steel to the exact location, often without being able to see it. At those times, he must rely on hand signals or radio. When a section of the structure has been assembled, workers will permanently fasten the members with additional bolts and welds. The special wrench that these workers are using will stop automatically when the required torque is achieved, ensuring that the connections are strong. Erection of structural steel has always been challenging. Many times, workers have to assemble very heavy pieces at tremendous heights, with several pounds of equipment and supplies hanging from them. They may have to walk on steel beams hundreds of feet up in the air. But the industry keeps a strict eye on safety, and safety requirements require workers to wear fall protection harnesses that help make erecting structural steel safe. The challenges of erecting steel structures aren't limited to safety issues only. Special conditions can require new and innovative techniques. For example, when extremely tall structures are being built, it may be impossible to find cranes that can reach the top of the structure from the ground. In such cases, self-lifting cranes may be used that can lift themselves as the construction proceeds. In the case of the CN Tower in Toronto, the tallest freestanding structure in the world, a mast had to be put in place over 1,500 feet in the air. Lifting and erecting this heavy steel structure safely and accurately at such a high altitude in Toronto's cold winter was a tough problem. The solution was a helicopter. After several practices on the ground where pieces of the structure were pre-assembled, a special helicopter was used to lift and assemble the mast. This solution saved over 6 months of construction time. In some cases, conditions don't allow much room for maneuvering. To construct the frame of the revolving restaurant at the top of the Space Needle in Seattle, the structure was assembled on the ground to make sure everything would fit before it was lifted and permanently assembled. Regardless of the type of structure, steel offers builders many advantages. Steel offers economy, durability, design flexibility, and simplicity. Steel can also be constructed very rapidly in all weather, and it allows structural changes and easy field repair. In addition, to protect the environment and save energy, steel is 100% recyclable. Production, detailing, fabrication, and erection. Those are the primary elements in building steel-based structures. Whether those structures are magnificent high-rise buildings or dramatically beautiful bridges, experts are required in every phase of the process. Experts who can turn scrap metal into high-quality steel. experts who can perform the complicated detailing that will transform an engineer's drawings into the specific requirements for